Today we're talking about congruent figures. A transformation is a function or mapping that results in a change in the position, size, or shape of a figure. The original figure is called the pre-image. So I'm just going to draw just a little picture here. This is a triangle. And then if I copy and paste it, I have an exact duplicate. All I have to do is move it right back on top and they will be congruent. So if this is called a translation. Translation just means it's been moved from one place to the other. So the original figure is called the pre-image, and the result of a transformation is called the image. A rigid transformation preserves distance. So I can have a translation, a rotation, or I could have a reflection. And all of these are rigid transformations. It's not going to change the distance of the sides of the triangle. Rigid transformations and composition of rigid transformations result in congruent figures. So if I move it around, if I rotate it, or if I reflect it, all of those are considered congruent. Two figures are congruent if there's some steps that make it so that one figure can map onto another figure. Two congruent figures below, I have A is congruent to E, and we can map that by the one line on the angle. Notice when we write the quadrilateral ABCD, the A and the E are first because those are congruent. Green is next with B and F. They're both the second one when we write our A, B, C, D, and E, F, G, H. Those are the same angle. C and G are the same angle. And notice there are 3 lines on C and G. Then we're going to go to D and H. We have 4 lines. Each one has a different number of lines, so you can tell which ones are congruent. On the next line, it's the corresponding sides. So if I take AB and EF, those we're going to put one line on the side. Those are congruent. Notice they're AB and EF in our quadrilateral up top are the same spot. BC is going to be congruent to FG, and we're going to put 2 lines on that one. The next one is CD and GH. There are 3 lines on that side. And notice C and D are the first and last letters, and G and H are the first and last letters. Just make sure that they line up when you label these. The last one is DA and HE. Those both have 4 lines. Let's look at some examples. If I look at example 1, we have triangle BAD, and it is congruent to REX. So I'm going to go ahead and label BA and D and RE and X. Make sure the B angle is the same as the R angle. The E is the same as the A, and the D is the same as the X. So I've got a purple line here. Angle B is congruent to angle R. And then angle A is going to be congruent to angle E. Now I put a pink line here, but if you don't have different colors, you can just do 2 lines instead of 1. Then angle D is congruent to angle X. Again, I've got it in green, but you could do 3 lines for this one like we did in the previous example. BA is the same as RE. They're in the same order. Make sure it's BA and not AB. And then we've got AD and EX are congruent. I've got 2 lines there for AD and EX. Then we're going to go to that longest side, and BD will be congruent to RX. Make sure when we're doing line segments, we draw a line on the top of what of the 2 points. So BA would be a line. We're going to put a line on top when we write it because it's a line segment. In example 2, we have 2 triangles. We have one ABC and we have one XYZ. We're going to go ahead and duplicate those triangles so that they are congruent. And then we are going to label them A, B, and C and X, Y, and Z. Make sure the A and the X are in the same spot, the B and the Y are in the same spot, and the C and the Z are in the same spot. Now, measure of angle A is 53, so in A we're going to write 53, and then in B it's 102 degrees. Well, since A is congruent to X, we can put 153 in both spaces, and then since 102 is the same, since angle B is the same as angle Y, they're both 152. So C and Z have to be that third angle. So if we take 180 and minus 53 and then minus 102, we're going to get our answer for angle C and angle Z. So let's go ahead and subtract those off. When we do that, we get 25 degrees for both angle C and angle Z. So since angle C is 25, Z will be 25 as well. Let's talk next about the third angles theorem. If we have 2 angles of one triangle that are congruent to each other, the third one also has to be congruent. We're going to go ahead and prove that third angle theorem in example 3. So I am given that angle A is congruent to angle D and angle B is congruent to angle E. So I'm just going to write given on my reasons. So the next one, we have the measure of angle A is equal to the measure of angle D, and the measure of angle B is equal to the measure of angle E. This is because of the definition of congruent. Now, the reason we needed to change it is to measures is because of this definition we had on the last assignment. Figures are congruent, measures are equal. So measures are equal, so we want to use the equality properties, so we need to change it to equals. Then we can subtract things off and we can set all of our triangles equal to 180 degrees. Now remember, all triangles the angles add up to 180 degrees. So we can use this a lot when proving triangles are congruent. So we know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, and the measure of angle D, the measure of angle E, and the measure of angle F all add up to 180 degrees because of that triangle angle sum theorem. Okay, so since A, B, and C add up to 180 degrees, and D, E, and F add up to 180 degrees, those have to be equal to each other. So on the next line, we're going to put the measure of angle A plus the measure of angle B plus the measure of angle C is equal to the measure of angle D plus the measure of angle E plus the measure of angle F. And that is because of that transitive property. If two things are equal to some number, then they're equal to each other. The next line says D, E, and C, and D, E, and F. We have to look and see what are they doing. Well, we know that D is equal to the measure of angle A, and the measure of angle E is congruent or is equal to the measure of angle B. So we can substitute those angles in for each other. So A became D and E became E, and we know that because they are congruent. The next line says the measure of angle C is equal to the measure of angle F because of the subtraction property of equality. The left side has the measure of angle D and the measure of angle E, and the right side has the measure of angle D and the measure of angle E. So we are going to subtract those D and E from both sides of the equal sign, and that will be the subtraction property of equality. That leaves us with the measure of angle C is equal to the measure of angle F. Well, we need to get it to just angle C is congruent to angle F, so we are going to use the definition of congruent, and we will just say angle C is congruent to angle F. We're going to use the definition of congruence to complete the proof. So if two figures are congruent, then all of their sides are going to be the same and all of their angles are also going to be the same. So let's just look at what is given. I've written it down here. We know that AD is congruent to CB. We know that DC is congruent to BA. ACD, this one here, is going to be congruent to CAB, which is this one here. Those two angles are the same. And then we have DAC is going to be congruent to BCA, which is this one here. So we have almost everything, but we haven't shown that this side here is the same, and then these two angles are also the same. So let's go ahead and say that AC is going to be congruent. So AC is going to be congruent to CA by the reflexive property. Whenever you have a line where two triangles share them, they're both going to be the same length, and it's kind of like a mirror image of each other. So reflexive, we kind of think of a reflection in the mirror, and so those would be the same. So we've got all the sides. Now we just need to show that angle D and angle B are congruent. We just learned about the third angles theorem, which says that if we have two of the triangles are congruent to one another, then the third angles are congruent to each other. So since we know that two angles are congruent, then we know that angle D has to be congruent to angle B by the third angles theorem. Now we've shown all the sides are the same and all the angles are the same, so triangle ACD has to be congruent to triangle CAB by the definition of congruent figures that we learned here.